Okay, so we're going to begin looking at chapter 5 from the Pure Year 2 book, which is called Radians. But actually, before we start looking at Radians, I want to go back a step and think about something you're much more familiar with, something you can see in this picture here, which is degrees. So we're used to measuring angles in degrees. It's what you've been doing since probably primary school, and they're very familiar units of measurement to us. If I say a right angle, you're thinking in your head automatically 90 degrees. You know that there's 360 degrees in a full turn, a full circle. There's nothing surprising or unusual here. But it's just worth, I think, reflecting on where degrees come from in the first place and why they're useful. There's a couple of reasons that we use degrees. One of them is very, very simple. It's just that there's a convenience to them. So if I want to take my 360 degrees, my circle, and I want to split it in half, well, I know that 2 times 180 is 360. So it's a convenience, easy to split in half. But actually I can go an awful lot further than that. If I just really quickly, I say quickly, it'll take a bit of time, list all the factors of 360. I've got 1 times 360, 2 times 180, 3 times by 120. It divides by 4 as well, 4 times 90, 4 right angles. 5 times by, what's 5 times 72? Okay, it's 5 times 72. 6, yeah, that's 6 times 60, we can do that one. Now 7 we actually can't do, but it's the first one we can't do. Then 8 times, what is 8 times? 8 is times by 45. I can do 9 as well. It's 9 times 40. I can also do 10. It's 10 times 36. I can't do 11, sadly, can't do 11, but I can do 12 because it's 12 times 30. 13 and 14, they're no good, but 15 works again. So I can do 15. 15 times, what is it? 15 times? 15 times 24, I think. 16 is no good, 17 is no good, but 18 also works. 18 times 20. And that is a complete list. There are only more factors of 360, but as you can see, we've got an awful lot. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 factors. And that's fantastically useful for all sorts of reasons. Not least of all, the fact that of the first 10 numbers, 9 of them are factors of 360. 9 out of the first 10 numbers will divide this neatly. So if I want to split it into 8 pieces, I can. And that is particularly useful when you're dealing with really practical stuff, like building things and shapes. If I want to make an 8-sided shape, well, 8 goes into 360 45 times. So an 8-sided shape has an external angle of 45 degrees, an internal angle of 135 degrees. These are all nice whole numbers. And that's true for all of these 24 different factors. They all give you nice, neat, whole number, easy to use answers. There is a reasonable argument, I think, to say that a metric system might be neater because we use metric for a lot of things. There is actually a metric system for angles that exists, but we don't use it because actually, although there's something nice about doing metric things and having everything in multiples of 10, there is an incredible convenience in being able to divide your numbers by this many things. It's exactly the same reason that we use 60s and 24s for time, because 60 minutes can be divided not quite by as many things, because 60 doesn't divide by 8 or 9, but actually the first 6 numbers it does divide by, and by 10. So 60 is incredibly useful, 360 even more so. And that's the reason we measure angles in degrees, essentially. There is another reason to do with navigation and It's really interesting, but it's not as relevant for most of the things that you're going to be concerned with. So 360 degrees in a circle, perfectly reasonable, logical thing, but basically it was selected because it's a very divisible number, and it's completely arbitrary apart from that. You could split that circle up into any number of pieces you wanted. It's entirely up to you. So 360 degrees, we're familiar with it, we're used to it, but it's arbitrary. It's just a selected number for convenience. There's no particular mathematical reason why 360 is a nice number to use, other than that divisibility. So what we're going to look at in this topic is a different way of thinking about measurements of angle and turning, and a way which is significantly more logical and makes a lot more sense mathematically. In fact, what we'll discover as we move through year 13 is that when we use this thing called a radian, a whole load of other maths becomes much, much simpler, makes way more sense, and in fact, some things are impossible in degrees, but completely simple and straightforward in radians. And you'll meet those things later on in year 13. But the key takeaway here is degrees, arbitrary. Very useful, very familiar, but completely arbitrary. We could have split that circle up into any number we like. Radians, really specific, really clearly defined, and incredibly useful. And so we're going to meet them in just a moment.